Hey, this is part 2 of section 2.7, solving absolute value inequalities. Example 6. Consider the following absolute value inequalities. Sketch their solution sets on the number line provided. What do you notice? So we have the absolute value of x is less than 5. Recall the absolute value of x means the distance away from 0. So I'm saying the distance x is away from 0. So let's put 0 here. I want that distance to be less than 5. Well, that means anything with a distance from 0 that's less than 5, so for example, if I put 4 there, that's less than 5. Or if we put -3 over here, that's also less than 5. So what's going to end up happening is that we get all the values from -5 to 5, but not including -5 or 5 because it's a strict inequality. So that's why they're empty circles. But now what happens when we change it to greater than 5? That means we want all the values with a distance bigger than 5. So that means I'm going to be all the numbers less than -5 and all the numbers greater than 5. And that's what that would look like. The solution to the absolute value of x less than a can be written as the compound inequality with and, namely, -a is less than x and x is less than a. Alternatively, we can write it as the double inequality, -a less than x less than a. What I tell students to remember this is because this is less than, it goes with and. So the than and the and almost rhyme. The solution to the absolute value of x greater than a can be written as the compound inequality with or, namely x is less than -a or x is greater than a. And again, it kind of rhymes if you pronounce it as great or and or. One way to remember which word goes with which inequality. And the same thing will be if they're less than or equal to or greater than or equal to. Example 7. How do things change if we add an equal to sign? Consider the following absolute values. Sketch the solution sets on the number line provided. Got a little ahead of myself with my last comment. But you will see if I want greater than or equal to 2, I'm just looking for values that are greater than 2 or equal to. So these are going to be filled circles now. And the same thing for less than or equal to. I want everything between -2 and 2, including -2 and 2. And I'll let you read through the notice there as well. Recall we can also describe these solution sets in interval notation. Go back and try it on the examples above. We can solve absolute value inequalities by rewriting the absolute value inequality as an equivalent compound inequality, which we can solve. Solve each inequality below, graph the solution set, and write in interval notation. So just like with equations, the first step is to get the inequality by itself, which I think all these examples have that already, yes. And once the absolute value is by itself, you're going to rewrite it. So here we're going to have x minus 7 is greater than 3, or x minus 7 is less than -3. And now I solve these like we did in section 2.6. We get x greater than 10 or x less than 4. And now I'm going to graph them. Greater than 10. Less than 4. And then smush them together because it's or. So there's the graphical solution. Then an interval solution would be -infinity to 4, parentheses, union, parentheses, 10 to infinity. part number 2. Again, it's going to be 6x plus 7 is greater than or equal to 9, or 6x plus 7 is less than or equal to negative 9. And now we're going to go through and solve these separately. And we get x greater than or equal to 1/3, or x less than or equal to negative 8/3. So again, graph them separately to begin with. And then smush them together. And then in interval notation, it would be negative infinity to negative 8/3 with a bracket, union, bracket, 1/3 to infinity. Then for number 3, we have the absolute value of 4z is less than or equal to 9. Well, we're less than or equal to this time, so that means we'll get 4z less than or equal to 9, and 4z is greater than or equal to negative 9. Solve these separate inequalities, get z less than or equal to 9/4, and z greater than or equal to negative 9/4. Graph them separately. But now this time, when I'm trying to graph the final solution, remember for the compound inequality and, we do not smush them together. Instead, we find just where they overlap. So they only overlap in the middle. So then our final answers are brackets negative 9/4, comma, 9/4, bracket. And finally, number 4. We get 2x minus 1 less than 7 and 2x minus 1 greater than negative 7. And now I solve these separately. Get 2x less than 8, x less than 4, and x greater than 0. So we get less than 4, greater than 0, and then they overlap between 0 and 4, not including 0 and 4, in interval notation 0, comma 4 with parentheses. And that's the end of section 2.7.